Good afternoon. Today we're going to look at solving 1- and 2-step inequalities. Remember, inequalities show two quantities, that should be TWO, two quantities that are not necessarily equal. Here are two examples. 5 is greater than 3. And -9 is less than 4. Remember, if we add, subtract, multiply, or divide both sides of an inequality, it should stay balanced. As in, if it's greater than, it should remain greater than. If it's less than, it should remain less than. Here's an example of multiplying both sides by 4. 5 is greater than 3. 4 times 5 is 20. 4 times 3 is 12. 20 is still greater than 12. But let's look at this one. -9 is less than 4. Okay, we are going to add -4 to both sides. We're going to add -4 to 9 and get -13. Add -4 to 4 and get 0. And yes, that is still true. -13 is less than 0. So when we multiplied by 4 and when we added -4, in both incidences, what we resulted in is also a true statement. It kind of stayed balanced, as we would say. But there is an exception in inequalities, and that is multiplying and dividing both sides by a negative. Notice that this is true. -4 is less than -2. We're going to do the same thing to both sides. We're going to multiply both sides by the -3. -4 times -3 is 12. -3 times -2 is 6. But this is no longer true. 12 is not less than 6. How do we fix this problem? When you multiply or divide both sides of an inequality by a negative, flip the inequality sign to keep it true. So if we flip the less than and make it greater than, then it's now true. 12 is greater than 6. So an exception in inequalities to keep things balanced is we have to flip the inequality sign if we multiply or divide by a negative number. Otherwise, the inequality will no longer be true. All the steps for solving equations are true for inequalities except when multiplying or dividing by a negative. So how do we solve this? -3x is greater than 12. Well, we divide both sides by -3. But the one thing we do is that since we divided by a negative, then we have to flip from greater than to less than. So x has to be less than -4 to make this equation true. So if we start out with the original equation and we plug a solution in it like -5, and so -3 times -5 is 15, and that is greater than 12, it is true. So our solution set are those things that are less than -4. Well, remember from the last lesson that in order to show our solutions, we have to graph it on a number line. The reason for this is there's more than one answer that will work. So in this case, x has got to be less than -4. So over here at -4, I know that my value at -4 is not allowed, so I'm going to put an open circle. But everything below that is allowed, so I'm going to shade that in, and that will go on forever and ever and ever. Any number below -4 would work. -5 worked, but so would -6, -7, -8, and so forth. Let's do a few examples. 3x is greater than 15. We have to undo the multiplication, and with that we do division. Then x is greater than 5, because the 3 divided by 3 is 1, leaving 1x. 15 divided by 3 is 5. So any number bigger than 5 will be part of our solution set. So we show that on a number line. Over here is 5. It can't equal 5. Notice here it cannot equal 5. It's got to be greater. So we put an open circle on the 5 and we shade it to the right. So not only do we want to solve it, we want to graph our solution. Here's another example. X divided by -3 is greater than 4. Well, the opposite to undo division, we do multiplication. So I'm going to multiply both sides by -3. Ding, 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 ding. We just learned something about that. If you multiply or divide by a negative number, in order to keep the inequality true, you have to flip the sign. 4 divided by -3 is -12, and these undo each other or cancel out. So x has to be less than -12. So on a number line, if 0 is in the middle, -12 will be somewhere over here, so I'm just going to mark it there. There's going to be an open circle because it is not equal to -12, and it's everything below that are answers. So not only so -12 is not an answer, but -13 is, and -14. -12.1 would be an answer. All of those are solutions, so we shaded in to show all the different possibilities that would make this equation inequality true, to make the inequality true. Here's another example. This time we have to undo two things. So we did two-step equations already. So we're going to undo the addition first. So the opposite of adding 10 is subtracting 10. Now we did not multiply or divide by a negative, so we do not flip our inequality symbol. Now we're going to divide by a +3, which again will not flip our inequality symbol. So any x value that's greater than 4 will make my original inequality true. So I'm going to do a number line. 0 is about in the middle. 4 is on this positive side, so I'm going to mark it on the positive side and label it a 4. Open circle is not equal to 4, and shade everything to the right. So any number like 5 or 6 or 7 or 8 and so forth will be solutions to the original inequality. Now we have this inequality. We are going to undo subtraction. So to undo subtraction, we add. That will undo the 12 and leave 32 on this side. We have to undo multiplication by dividing. Oh, ding, 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 ding. We've divided by a negative. That means to keep the inequality true, we must flip the inequality sign. So x has to be a value greater than or equal to -8 for this to be true. So then in order for us to graph it on a number line, -8 is over here. Oh, look, we have the equal to part. So we're going to make a closed circle, and we're going to shade everything to the right. So none like 0 would be okay for an answer. 8, 1, 7, 15. Any number greater than or equal to -8. So even -8 would make the original inequality true. Now for this example. The only thing we need to undo is subtraction. So to undo subtraction, we add. Both sides, remember, to keep it in the same inequality, to be the same, to keep that balance of the inequality, you have to do the thing to the left and right side. So negative 8 plus 5 is negative 3. So any x value that's greater than negative 3 will make the original true. So I will have negative 3 is on this side, not equal to, so we have an open circle. Every value to the right of negative 3 will make the inequality true. Now you're going to get a chance to try it for yourself. So you will be receiving a worksheet from your teacher, and you will practice this some more. So use your notes you just took and do the practice questions to work on solving inequalities with 1 or 2 steps. Have a great day.